Hello, and welcome to the operation that is Replay for Kids. My name is Dominic, and today I'll be walking you through the ins and outs of 3D printing, specifically regarding the switches and buttons that we print here at Replay. If you'd like to skip around at all, feel free to use the timestamps over here, or use the embedded chapters in the YouTube timeline below. In my time here at Replay, I've designed three main types of switches. There's the large surface big button, there is the easy touch switch, and there is the small button. I know, creative names. But for this video, we're just going to focus on the easy touch switch, which comes apart in two pieces and has a single button here that is hot glued and soldered in. We'll also be focusing on the small button, which comes apart in three pieces like this and has that same button, which is soldered the exact same way as you'll see in the soldering portion. This just makes it so a child who does not have the dexterity or ability otherwise to operate their toy can still play with their adapted toy using an accessible switch. I won't be walking you through all of the basics because every 3D printer is different and there are tons of YouTube videos out there explaining such things. But you should be familiarized with a couple basics such as bed leveling if yours is not automatic, Z offset, printer tool and bed maintenance, and of course, replacing filament. As always, before you print, ensure that there is enough filament left on the spool to complete the print. If there is not enough filament, this can be damaging to your printer at worst, or at best, it will be a waste of material since your print will come out half finished. The two methods that we will be working with to print the switches are STL and G-code files. An STL file is simply a 3D model. Your printer cannot print using an STL file alone, and as a result, this will require more work, which will be covered in the settings section at the end of the video. G-code, on the other hand, is much more plug and play. It is essentially an STL file, but with instructions for your printer on how to create the 3D object. You can give this file directly to your printer and go, which is why this method is recommended. The only worry with G-code is that your printer may not be compatible with our G-code file. To ensure that it is, stick around for, or skip to, the settings section at the end of the video. Removing prints from the build plate is not always as easy as it seems. If you have a flexible, removable build plate, go ahead and ignore this section. As for the rest of us, the technique that I recommend is using a knife or metal spatula to press into the point where the print meets the bed and gently pry up in a rotating motion. If the switch does not come off immediately, work around the edges until it pops off. Prying too hard in one spot will bend or damage the switch. The easy touch switches are generally simple to remove, whereas the small buttons can be tricky at times. This process does become easier with practice, so try to be patient at first. Support material is a necessary part of 3D printing, and as a result, most of our pieces use some level of support. To remove these supports, I typically recommend pliers to get the bulk of the material out, and wire cutters to clean things up. In certain cases, a knife can also be useful, but it is also more dangerous. The small button support can be pulled out with little issue using pliers alone in a pinch and pull technique. Wire cutters work well for more detailed cleanup. The easy touch switch can be done with pliers using a pinch and pry method to remove strips one at a time. Once all of the strips are removed, additional material may remain in the hinge cavity. The hinge of the easy touch switch is the only part that can be more difficult. Wire cutters or tweezers are often necessary to get the material from this small crevasse, and it is especially important to make sure all of the material is removed here because the bottom section of the hinge will not fit otherwise. In order to install the switch, you'll need a few materials: helping hands, wire strippers, pliers, a soldering iron, solder, a button, and jack wire. You will remove two of the prongs from the button and then flatten them out using the pliers. The side does not matter as long as the two prongs that you remove are from the same side of the button. If you're doing an easy touch switch, make sure that your wire is through the switch before doing any soldering. Next, strip the black casing off the wire using the 16 gauge in your wire strippers. Twist together the exposed wires to separate them from the white one, and then strip the white wire using the 26 gauge in your wire strippers. Twist the newly exposed wires as you did before and clamp both the button and the wire into your helping hands. If you haven't already watched the soldering safety video, the link is below, and you should do that now. Otherwise, go ahead and solder each wire to one prong of the button. When complete, seat the button into the switch and test it. If working, proceed to hot glue around the metal contacts as well as the wire within the switch. Separating the metal components will prevent the circuit from accidentally being completed. When you are done, reassemble the switch and test it again to ensure that it still works. In this section, I'll be covering both the use of G-code and STL files. To start off, G-code is easier to use, but I'm going to have to warn against it unless you are certain that our G-code will work for your printer. Certain things to look for are that your printer can reach speeds of at least 60 millimeters per second, that it can reach temperatures of at least 215 degrees, that it has a bed size of at least 8 inches by 8 inches, that it can reach bed temperatures of at least 60 degrees, and that it can print at a layer height of less than 0.2 millimeters. If you have the time, I would really recommend using the STL files provided and use the settings that I will go over in the next section. For those that do want to try using the G-code, what you can try first to make sure that it works for you is printing out the 1 centimeter by 1 centimeter by 1 centimeter cube that I have provided. If this prints out and is the proper dimensions, it is likely that the G-code file will work for you. But if anything goes wrong in the printing of the cube, I would strongly recommend using the STL files instead of the G-code for the buttons. Now for the fun part. When you're using STL files, the settings can easily be overwhelming if you are not familiar with 3D printing. But I'll try to give a clear description of what each setting does and why I am setting it to a certain value. To start, I am going to recommend that you use Cura. Cura is a free, online, and open source slicer that is great to use and very user-friendly. You will see while I'm doing this tutorial that I'm using the advanced settings. To find the advanced settings on your Cura slicer, first click the parameters here, then go down to Show Custom, hit the hamburger menu next to the search bar, scroll down to Advanced. Now the first thing I'll do is queue up an example print. Here's an example of how the files might initially be placed on the build plate when you open the STL. Move around your objects, rotating if necessary, until they are all flat and fitting within the parameters of the build plate. Once all your pieces are properly oriented, we can focus on the settings. We will mainly be looking at quality, top, bottom, material, speed, cooling, and support. We're going to start off by changing our layer height to 0.3. This is essentially reducing the resolution of our print. This will save us time in the long run, although our print won't look quite as good as it would otherwise. Moving on to top and bottom. We're going to change our top and bottom layers to 2 each. This will save us both material and time because more of the part will be made up of infill. Moving down to material, depending on if you're using PLA, PETG, or another material, I know that PLA typically prints around 210 degrees Celsius with a bed temperature of 60 degrees. PETG, on the other hand, usually prints around 230 to 240 degrees Celsius. If you have another material, you can look on the packaging and usually find the details there. Moving down to speed, I'll typically set my print speed to 60 millimeters per second, although you'll have to check the specs of your printer to see if it can handle such speeds. As far as wall speed and top and bottom speed, I'll set each of those to 55 millimeters per second. Initial layer speed I typically bump to 35 millimeters per second. Each of these speed bumps I've determined does not sacrifice quality but will save time in the long run. Moving down to supports, we're going to want to enable the generation of supports and then change support placement to touching build plate. This will make sure that only portions of the build that are touching the build plate receive support. Now we're going to move down to support density and change that to 9%. This will save us filament and time in the long run and also make the supports a lot easier to remove. Finally, let's move down to build plate adhesion. A skirt is great, but a skirt line count of 3 is a bit excessive. I typically only use 1. Now let's do a final slice. Our build comes out to 1 hour and 42 minutes of print time and 27 grams of material. For comparison, Let me go back to all of the default settings and then slice it again. As you can see, without our modifications, this print would take 3 hours and 51 minutes and 28 grams of material. If you go to the Preview tab, you can see what each layer will look like, and if you rotate under, you can see the support that is generated under the cap of the button. You can also see the skirt that will be generated around the build. And with that, our time together comes to a close. I hope you were able to learn something in the process, and if you have any further questions, feel free to post those down in the comments. That's all from me. I hope you have a lovely rest of your day. Thank you.